Welcome to another episode of Euricalia. Today, we embark on an awe-inspiring journey to explore the heart of our solar system, the radiant and magnificent Sun. Billions of years ago, a vast cloud of gas and dust, known as a nebula, began to collapse under its own gravity. As the nebula contracted, it started to spin, forming a rotating disk. At the center of this disk, an incredibly hot and dense core began to take shape. The temperature and pressure at the core increased, leading to nuclear fusion reactions. Hydrogen atoms fused together to form helium, releasing an immense amount of energy in the process. This nuclear fusion is what powers the Sun and makes it shine brilliantly. The energy generated in the Sun's core takes millions of years to reach the surface, where it finally escapes as sunlight, illuminating the entire solar system. The Sun's significance in our solar system cannot be overstated. As the largest celestial body, it holds over 99% of the mass of our solar system. The Sun's immense gravitational pull keeps the planets, including our home, Earth, in their stable orbits. It acts as a celestial anchor, preventing the planets from drifting aimlessly through space. Beyond its gravitational influence, the Sun is the ultimate source of energy for life on Earth. The sunlight that reaches our planet drives weather patterns, ocean currents, and the growth of plants through photosynthesis. Photosynthesis is a remarkable process that converts carbon dioxide and water into oxygen and glucose, providing the foundation of Earth's ecosystems and supporting almost all life on our planet. Solar energy also plays a crucial role in our daily lives, as it can be harnessed through solar panels to produce clean, renewable electricity, reducing our reliance on fossil fuels. While the Sun may appear serene from a distance, it is anything but quiet. The Sun's dynamic surface is often punctuated by dramatic events known as solar flares. Solar flares are powerful explosions that occur when the Sun's magnetic fields become twisted and release vast amounts of energy. These eruptions unleash a torrent of high-energy particles and radiation into space. When these charged particles reach Earth, they can interfere with our planet's magnetic field and cause space weather events, such as geomagnetic storms, that can disrupt satellite communications and power grids. Sunspots, on the other hand, are temporary dark regions on the Sun's surface. They are caused by the Sun's complex magnetic activity. Sunspots often occur in pairs and can vary in size and shape as they move across the Sun's surface. They are cooler than the surrounding areas and appear dark against the Sun's glowing surface. The Sun's atmosphere is a captivating and intricate structure, comprising several distinct layers. The visible surface of the Sun, the part we can see from Earth, is called the photosphere. The photosphere is about 300 miles, 500 kilometers, thick and has an average temperature of around 10,000 degrees Fahrenheit, 5,500 degrees Celsius. Above the photosphere lies the chromosphere, a region of faint, reddish light. The chromosphere is only visible during total solar eclipses, creating a breathtaking ring of light around the darkened Sunday. Beyond the chromosphere is the corona, an ethereal aura of plasma extending millions of kilometers into space. The corona is incredibly hot, with temperatures reaching several million degrees Fahrenheit, over 1,000,000 degrees Celsius, even though the photosphere beneath it is much cooler. Understanding the corona is a fascinating challenge for scientists, as its extreme temperatures defy conventional thermodynamics. Like all stars, the Sun has a life cycle with distinct phases. Currently, the Sun is in its main sequence phase, where it steadily fuses hydrogen into helium in its core. Over the next few billion years, the Sun will continue to burn hydrogen, but as it does so, its core will contract, and its outer layers will expand. In about 5 billion years, as the Sun exhausts its hydrogen fuel, it will start fusing helium in its core, while its outer layers will expand further. This expansion will cause the Sun to enter its red giant phase. During this phase, the Sun will grow so large that it will engulf Mercury, Venus, and likely Earth as well. As the red giant phase progresses, the Sun will shed its outer layers, forming a beautiful planetary nebula, leaving behind a dense, hot core known as a white dwarf. This serene white dwarf will be the remnant of our once radiant Sun. The Sun's effects extend far beyond its gravitational pull. Solar activity, such as solar flares and coronal mass ejections, can lead to solar storms that influence Earth's space environment. When these storms reach our planet, they can cause geomagnetic disturbances, affecting our magnetic field and generating beautiful auroras in polar regions. Solar storms can also interfere with satellite communications, disrupt power grids, and pose risks to space travelers. Studying solar activity and its impact on Earth is vital for understanding space weather and safeguarding our technological infrastructure. Our Sun is just one of trillions of stars in our galaxy, the Milky Way. However, beyond our galaxy, there are countless other galaxies, each harboring its own set of stars. These distant suns come in a myriad of sizes, colors, and ages. Some may be similar to our Sun, while others might be massive blue giants or dim red dwarfs. Recent discoveries of exoplanets around distant stars, some in their star's habitable zone, have sparked interest in the search for potentially habitable worlds beyond our solar system. The study of other Sun-like stars and their planetary systems provides valuable insights into the diversity of celestial bodies and the possibility of life beyond Earth. Throughout human history, the Sun has held profound cultural and spiritual significance for civilizations around the world. Ancient cultures often worshipped the Sun as a deity, associating it with life, fertility, and power. Many civilizations built impressive structures and monuments that aligned with the Sun's movements, often serving as calendars or markers for important celestial events. In Egypt, the sun god Ra was a central figure in religious beliefs, and the sun was a symbol of renewal and rebirth. In ancient Mesoamerican cultures, such as the Aztecs and Mayans, the sun played a vital role in their religious ceremonies and was considered a source of cosmic energy. The cultural significance of the sun continues to resonate in modern society, with various festivals and holidays dedicated to celebrating the solstices and equinoxes. Over the centuries, humans have endeavored to observe and study the sun through various means. From ancient cultures using sundials to track time, to the invention of the telescope by Galileo Galilei in the 17th century, our understanding of the sun has evolved significantly. Today, we have sophisticated solar observatories and space-based telescopes that provide detailed views of the sun's surface, atmosphere, and solar activity. One such observatory is the Solar Dynamics Observatory, SDO, launched by NASA in 2010. The SDO continuously observes the sun, capturing high-resolution images and data, helping scientists understand solar flares, sunspots, and other solar phenomena. The Parker Solar Probe, launched in 2018, is an audacious mission designed to study the sun up close. It approaches the sun's surface at a distance of just a few million miles, braving intense heat and radiation to investigate the mysteries of the sun's corona. These groundbreaking missions and observations expand our knowledge of the sun and offer us insights into the fundamental processes that govern stars in our universe. We hope you've been captivated by the incredible science fun facts about our radiant cosmic neighbor. The sun is not only essential to life on Earth but also a gateway to exploring the wonders of the cosmos. Until next time, keep looking up and exploring the universe. Thanks for joining us on today's episode of Euricalia. Stay curious, keep experimenting, and may your adventures be filled with discoveries.